Most Apex developers write code that works. It inserts records, updates fields, runs queries. But there's a quiet security gap in most code bases. Apex runs in system mode by default, which means it completely ignores field-level security. A profile that can't see the industry field? Your Apex writes to it anyway. The Describe API is what closes that gap. This session is a complete walkthrough, from the basics of reading schema metadata to a production-ready utility class your entire org can use. Salesforce orgs aren't static. Admins add fields, rename objects, tighten profiles, install packages. Your Apex code has to survive all of that without breaking or silently behaving incorrectly. The Describe API is Salesforce's answer to this. Instead of hard-coding assumptions about what fields exist or who can access them, you ask the platform at runtime. 3 situations make this non-negotiable: enforcing FLS before DML, building dynamic SOQL from configuration, and writing generic utilities that work across any object type. Here's the gap that catches developers off guard. When Apex runs, whether from a trigger, a controller, a batch job, it runs in system mode. That means it ignores field-level security and, depending on context, object-level CRUD permissions too. For backend automation, this is often intentional. But for user-facing code, LWC server actions, or controllers, Visualforce, you're acting on behalf of a real user who may not have access to certain fields. If you don't check, your code silently violates those restrictions. The platform won't always stop you. You have to stop yourself. The Describe API lives inside the schema namespace. Everything flows from 2 result types. The first is Schema.DescribeSObjectResult. This gives you object-level metadata. Think of it as the spec sheet for an entire object. Its API name, its label, whether users can create or delete records, whether it's a custom object. The second is Schema.DescribeFieldResult. This goes one level deeper and gives you everything about a specific field: its data type, length, whether the current user can read or write it, and for picklist fields, its list of valid values. To get a DescribeSObjectResult, you have 2 options. The first is the dynamic approach. Call Schema.DescribeSObjects and pass in a list of SObject API names as strings. This returns a list of results in the same order. You'd write Schema.DescribeSObjectResult account describe equals Schema.DescribeSObjects. New list string account 0. From there you can call getName, getLabel, isCreateable, isQueryable, and isCustom. This approach is useful when the object name comes from a variable or configuration you don't know it at write time. The second approach uses compile time token syntax. When you know the object type while you're writing the code, you can write Schema.DescribeSObjectResult account describe equals Schema.SObjectType account, or equivalently, account.SObjectType.getDescribe. This is faster because Salesforce can optimize it at the platform level, and it has a huge safety benefit. If you make a typo, the compiler catches it immediately. The build fails instead of your code throwing a null pointer exception at runtime in production. Prefer this syntax whenever the object is known at compile time. Once you have a DescribeSObjectResult, you can drill into individual fields. Every object describe exposes a field's property. Call .getMap on it, and you get a map keyed by lowercase field API name. Each value is a Schema.SObject field token. Then call .getDescribe on a token to get a describe field result. From there, getLabel gives the human-readable name, getType gives the data type as a Schema.DisplayType enum, getLength gives the character limit, and the FLS flags isAccessible, isUpdateable, and isCreateable tell you what the current user can actually do. The getType method returns a Schema.DisplayType enum value. This is useful when you need to branch on field type, for example, to skip reference fields in a copy utility or to format values differently in a data export. The full set of values includes string, Boolean, currency, date, datetime, double, email, ID, integer, picklist, multi-picklist, reference, text area, and more. Think of display type as the field's category. It tells you not just what the field holds, but how to handle it programmatically. You'll use it in conditionals to filter or process fields differently based on their type. Here's the FLS check pattern you should use in every piece of user-facing code that writes to a field. Before the DML, check 2 things. First, can the user update this object type at all? That's Schema.SObjectType, account.isUpdateable. Second, can they write to the specific field? That's Schema.SObjectType, account.fields. phone.isUpdateable. If either check fails, throw system.NoAccessException. Do not proceed. The compile time token syntax is the right choice here because the object and field are known when you're writing the code. It reads clearly, and the compiler validates the field name exists. When you know the object and field names at compile time, always use the compile time token syntax. It's faster, it's validated at build time, and it reads clearly. The syntax is Schema.SObjectType, account.fields, phone.getDescribe. When the object or field name is dynamic, coming from a config record, a custom metadata type, or user input, you have to use the string-based map lookup instead. You call Schema.DescribeSObjects, get the field map, then look up by lowercase string key. Both approaches work. The choice depends on whether you know the name when you write the code or only when it runs. A common pattern in utility classes is building a SOQL query that includes all fields the current user can read, useful for audit logs, record exporters, or clone utilities. The approach, call fields.getMap. On the object describe, iterate the map, call isAccessible on each field's describe result, and collect the API names of fields that pass. Then join them with string.join, and assemble your select clause. Important, the where clause must come from trusted input only. Never concatenate raw user input into dynamic SOQL. That's a SOQL injection vulnerability. Use database.query with binds for user-supplied filter values. For picklist fields, DescribeFieldResult exposes a getPicklistValues method that returns a list of schema.picklistEntry objects. Each entry has three key methods. GetValue returns the stored database value. GetLabel returns the display text shown in the UI. These can differ. IsActive tells you whether the entry is currently available for new selections. Inactive entries may still exist on records inserted before they were deactivated, but shouldn't be offered to users. Think of picklist entries like menu items. Some are still on old receipts, but no longer on the menu. A practical use of picklist describe, validating incoming values before insert. If a value arrives from an external system or an API integration, it might be a valid string, but not a valid picklist entry. Instead of letting the database reject it with a generic platform error, you call getPicklistValues. Build a set of active values, and check contains key before attempting DML. If it's invalid, throw a clear error with the field name and the bad value. This gives the caller meaningful information to act on, rather than a cryptic exception from deep in the DML layer. Describe calls are expensive. Every call to schema.describeSObjects or fields.getMap makes a metadata request that adds to your transaction overhead. In a bulk context, a trigger processing 200 records, a batch job iterating thousands. Calling describe inside the loop multiplies that cost by the record count. The fix is caching. Create a utility class with static map variables. The first call populates the map. Every subsequent call in the same transaction returns the cached value instantly. Static variables persist for the lifetime of the transaction, so you pay the describe cost exactly once regardless of how many records you process. The most common describe mistake is calling it inside a for loop. It looks innocent. You're just getting field metadata on each iteration, but you're making a metadata request for every record. Pull the describe call above the loop boundary. Get your describe field result or your field map once. Assign it to a variable, then reference that variable inside the loop. This applies even if you're not using a cache utility class. The rule is absolute. Describe never goes inside a loop. If you find yourself wanting to describe different objects per iteration, build a map outside the loop and populate it dynamically as new object names appear. Here's what a good schema cache utility looks like. 2 static maps. 1 key by object API name holding DescribeSObjectResult. 1 key by object name holding the field map. Each getter method checks contains key first. If the key is missing, it calls describe and stores the result. If it's present, it returns immediately. Your calling code never calls describe directly. It always goes through schema cache. The describe call happens once. The cache hit costs almost nothing. You can call schema cache.getFieldDescribe, account, industry, inside a loop 200 times, and the describe runs exactly once. With caching in place, build a safe DML utility. The idea: centralize your CRUD and FLS checks so you don't repeat them across every controller, trigger, and service class. SafeDML.assertInsertable takes an SObject and a list of field names to check. It gets the object's API name from the records type token, checks isCreateable on the object, then loops the field names, looks each one up in the cached field map, and checks isCreateable on each field's describe. If anything fails, it throws NoAccessException. The DML never runs. The check is the gatekeeper. SafeDML.SafeInsert wraps assert insertable and then calls insert. Usage in a controller looks like this. Create your account, set its fields, then call SafeDML.SafeInsert, ACC, new list, string, name, phone, industry. If the running user's profile restricts the industry field from being created, the method throws before touching the database. No silent write. No confusing platform error from the DML layer. The caller gets a clean NoAccessException they can catch and surface to the user with a meaningful message. SafeDML.SafeUpdate works the same way using isUpdateable. 3 rules make Describe production ready. First, cache everything in static variables. Describe runs once per transaction, not once per call. Second, use compile time token syntax whenever the object and field names are known at write time. It's faster and compiler validated. Third, always check FLS explicitly in user-facing code before DML is creatable on insert, is updatable on update, is accessible before returning field values. These aren't optional practices. Apex will not enforce FLS for you. The difference between secure user-facing code and code that silently violates permissions is these 3 checks. The full Session 58 article at realsyllabus.com has everything covered here as complete, compilable code. The schema cache utility, the FLS check patterns, the dynamic field query builder, the picklist validator, and the full SafeDML class ready to drop into any org. If you're building anything user-facing in Apex, LWC server actions, Aura controllers, API endpoints, this is the session to work through. Bookmark it, implement the cache utility first, then work the FLS checks into your existing DML calls one class at a time.